we already went through two examples on Riemann sum. Okay, so once again, Riemann sum is the area of rectangles under the graph, and the more accurate we divide, the more rectangles that we include, the more accurate this whole thing is. Okay, so the thing is that we did a little bit of Riemann sum over here. Okay, we added rectangles or area rectangle height times base. Okay, and then we did a little bit of integration to find volume. Okay, and then we went on to this question also. This one looks a bit more challenging, but the thing is that you just need to observe the structure to get the final answer. Okay, you don't need to do this long, but I'm showing you this long because step by step working, but you don't have to do this long really. Okay, you just tailor by marks and see what you need to show. Okay, now we left some parts hanging over here. Okay, we left some parts hanging over here. So let's now try to do all these things. Okay, can Okay, so let's continue with part B very quickly. Okay, previously in part A, we were integrating this fx itself. Okay, so because we are trapped by this square root, so what we needed to do was we had to consider the relationship between denominator and numerator. So you check whether if this is f prime and f. Okay, turns out it is. Okay, turns out it is, or we can change it to the f prime f form. So we just make use of some basic algebraic juggling to get what we need. This one, we are integrating power function. Okay, so this is your f prime. But what are we integrating? The power function. Okay, this one itself is a square root function, but there is a square minus x square over here. So this thing is actually our inverse sign, making use of the formula. Okay, so this is part A. Part B. Okay, part B. We are going to continue to do this. So we are asked to evaluate the whole thing square. 3 plus 2x minus x squared dx. Okay, so let's double check. Okay, let's double check. This one over here, what's the degree? 2. The one at the bottom, what's the degree? 2 also. So this means that this is an improper fraction, right? So we need to do long division and partial fraction. Okay, so over here, okay, you need to do your long div and partial fraction, which sadly doesn't carry any marks. Okay, they only look at the what do you call this? They only look at the final result. Okay, so means that we will only get something like that, -1 plus 9 over 4 3 minus x plus 1 over 4 1 plus x dx. Okay, so if you can do the so only 3 marks, right? First mark is to change to that form, long div and partial fraction. Okay, so that's the first mark. Okay, so this one is A math, so I let you do, but you do fast. If you can do cover up rule, you please do cover up rule. Okay, use your hand to cover your eyes and just hopefully everything will go. Not kidding. For example, you need to factorize this. Factorize this to 3 minus x and 1 plus x, correct? Right? So the thing is how you will get something like an A over this and B over this, right? Correct? Right? So for example, if you want to find the value of A, you cover up this, you cover up the 3 minus x over here, you cover up. Here you got 1 plus x, like that. Can you imagine? Then you sub x equals to 3 over here. Okay, substitute over here, you should get 9 over 4 lah. Okay, can something like that. Because what we are doing over here is the cover up rule method process lah. Okay, so with that, how do we integrate this? Very straightforward. This one will be just x, negative x, plus 9 over 4. Okay, and then because of the reverse chain rule, I got negative half ln 3 minus x plus 1 over 4 ln 1 plus x plus c. So altogether, negative x minus 9 over 8 plus 1 over 4 ln of this. Now let's also double check whether do we need to keep the modular signs or not. Okay, detail, now is the detail part. Okay, double check this one over here. Okay, between -1 and 3, right? Okay, so let's observe. If we sub in any value between -1 and 3 strictly, okay, strictly between -1 and 3, this one will still be valid, correct? All this will still be valid. So because of this, okay, we can actually drop the modular sign, okay, and we can put these brackets over here, okay. Okay, can so yeah, the detail part. Now then the thing is in A level, how detailed do we need to be? Let's say if you want to play safe, leave it as modulus. Okay, otherwise you can do this. Can now if it's a show question, then you need to explain why. Okay, you need to do the explanation. It's valid for -1 less than x less than 3. Okay, can. So this is part B. Yeah, it's cannot equal. It's strictly less than and strictly more than. Okay, part two. Part two, we are required to find the area bounded by the curve, the x-axis, and the lines. Okay, so you can roughly sketch. Okay, you can roughly sketch and see how does this graph look like. Okay, so very quickly, let me go to your calculator. Faster, faster, faster. Sorry, taking a while. Five, six, seven, 8, 9, 10, 11, 12, 13, 14, 15. Okay. Yes. Yeah. Answer the same answer key. Oh, 9/4. Oh, because of my 2x. I'm wrong. My 2x is not there. Yeah, it's 2x. As in, it's not 2x. So I don't need to divide by 2. Okay, my bad, my bad. Okay. Okay. Now, before I continue, let me change something. Sorry, I see wrong. Actually, don't need this. This one don't need. Yeah, the half don't need. So actually, this one is plus 9/8. 9/4. Okay. Paise. Okay, my bad. Okay. Now, going back to this, right? Let's plot y equals to x over square root of 3 plus 2x minus x squared. Okay, you see something like that, right? Okay, you see something like that. Okay, the next thing to also test is where is, okay, you really don't have to sketch. You just look at your GC and you can tell already. Okay, but okay, you can roughly see that you have something like this lah. Okay, you have something like this. Now the thing is, where is 1 minus root 3? Okay, so where is 1 minus root 3? Okay, you can go back to the original one. So 1 minus root 3 is, okay, negative 0.7. Okay, which is less than 1. Okay, so it means we are going to look at something over here. So this is x equals to 1 minus root 3. Okay, really don't have to draw because you just need to visualize. Because here, right, you should have an asymptote of -1. Okay, and then here you should have asymptote of 3 lah. This is what the range means. The range where it's well defined. Okay. Okay, you have this one over here, and then you need all the way until 2. Okay, so this one is x equals to 2. So the area that we are looking for, Okay, means it will be this area over here. Can see how? Okay, you really need to use your GC to sketch and see lah, or else to really plot and see. But you can visualize it's going to be like that. So for the negative part, okay, the shaded area for the negative part, we will have to take the negative of from 1 minus root 3 to 0 of this thing. Okay, then for the positive part, we are going to integrate from 0 to 2 of the same thing. Okay, can Okay, now we've already integrated this in part 1. So technically speaking, we can just quote the answer directly from there. So sine inverse x minus 1 over 2, okay, minus this thing. Between this, okay, and plus this. Okay, from 0 to 2. Okay, so when you sub in, we will get something like, okay, sine inverse of half minus root 3. Okay, then minus of sine, right, correct, right? Okay, sine negative root 3 minus 2 minus square root of 1. Okay, when you put in, you'll get a nice square root of 1. Okay, now then for the second bracket, you will have something like, okay, sine inverse of half again. Okay, sorry, this one negative half. Okay, then minus root 3, then minus sine inverse of negative half. Okay, substitute the values. Okay, minus root 3, like that. Okay, so all together, right, you will have, okay, can so all together, right, once you simplify all the way, right, this one I let you do patiently. Okay, you should be getting pi over 6 plus root 3 minus 1. Okay, so this root, yeah, something like this will still be there. This plus root 3 will minus the root 3 lah, that kind of thing. Or you minus and plus back will cancel off, that kind of thing. Okay, then your this and this and this and this, right, will cancel out some one way or another. Okay, to get your pi over 6. Can So you just evaluate angle, 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 and angle. Don't worry. Okay, just evaluate these angles. Okay. Now then for part 3, we are looking at the volume. Okay, we are looking at the volume generated when the curve is bounded between that is rotated completely about the x-axis. So means that now, right, we are considering this portion. Okay, we are looking just at this region and we will rotate this region 360 degrees. Okay, just rotate. Can Okay, so for part 3, right, the volume, okay, would be, okay, revision pi y square dx. So over here, this would be pi, integrate from 1 to 2, y square dx. So x square over this one, 3 plus 2x minus x square dx, which we have already done previously. So this one from the previous part, right, we will get okay, negative x minus 9 over 4 ln 3 minus x plus 1 over 4 ln 1 plus x. Okay, then from 1 to 2. Okay, huh? Okay, so you just sub in slowly. Okay, this will be ln 1. So this will be 0. Okay, so altogether, pi on the outside, you can simplify to 1 over 4 ln 3 plus 2 ln 2 minus 1. Okay, something like that. Can ah? Okay, so this one straightforward already at the end. Okay, once you manage to integrate part 1, then 2 and 3 should be straightforward. Okay, you just need to visualize where, especially for area, need to visualize. Okay, volume not so bad, more straightforward, but still need to see which area minus which area. Okay. Okay, so with this, let's continue on to the next chapter. Okay, next chapter, right? We are actually looking at. Okay, next chapter we are actually looking at binomial Maclaurin. I won't spend so much time for question 4 because question 4 I already go through in 29, 25, 29. Yeah, in 29 already. So I will just skip that. But the idea is repeated differentiation. Question 1. Um, implicit differentiation. Mm. Implicit. Okay. Okay, can okay, I'll just quickly flash through since we have already done. Okay, can all right. Okay, so let's take a look at this one. I'll just go through very quickly, because I've already done this in another class. I'll just flash you the answers from there. Okay. Okay, actually I don't have the answers from there. I know right now. Okay. Okay, idea is right from this question, right? How do we differentiate this very efficiently? Because we have a function within a function, right? So if we want to differentiate, okay, okay, if we want to differentiate, the thing is we'll need to use chain rule, and it's very sad. Okay, so the clue over here is that you have an x square, you've got dy dx, and you have a y square. Okay, you have your x, your y, and your dy dx. So this tells us that we need to differentiate this implicitly. Okay, so how do we differentiate this implicitly? Shift this tangent over here. So I will get tangent inverse y is equals to half tangent inverse x, like that. Okay, then when you differentiate tangent inverse, have you learned this before? Differentiation last year. Okay, can so you do differentiate from here, then you can see this structure straight away already. Okay, come, let's log in. Okay, otherwise I'm not doing you justice. Also, you don't have to come. Yeah, but can okay. So we need to differentiate a few times. Okay, we go up to x cubed and then we find that term. Okay, then part 2 is the one that I just want to quickly say. Okay, so fx is this. So this one over here is f. Okay, your answer over here, this is gx. Okay, so given that the range of values of x, okay, for fx differs from gx by less than 0.1 is this range. Find the value of a giving your answer to 3 significant figure. Okay, so this one over here, okay, I quickly give you the idea. Okay, so what we need to do is translate English to maths. Okay, so we will take fx minus gx, right? Correct? Less than 0.1, correct? Okay, however, this is wrong. This one over here, if you think about it, you can swap gx minus fx. What happens if you do that way? You still get a difference, right? Correct? But the difference must be between 0.1. Okay, must be less than 0.1. So you should be taking the modulus. can be a positive or negative difference. Okay, and because of that, when you open up the modular sign, okay, when you open up the modular sign, you get something like this already. Okay, now let's test run and see what are we supposed to do. Okay, you don't have to write this. Okay, so we are looking at something like this. Tangent, half tangent inverse x minus of your half x plus kx cubed lah. Something like that, less than 0.1. Okay, problem. Are we able to solve this algebraically? No, a bit weird, right? So because we cannot solve algebraically, what are the other methods for us to solve inequalities? Chapter 2. Okay, there is the algebraic method. There is also the graphical method. So we need to make use of GC to plot. Okay, so we will need to plot this thing in your GC. Okay, so I think my guess would be from here, straight away, or maybe from here, you can plot something like this. Yeah, I'm just guessing. I don't know. Yeah, I'm just guessing. Okay, can. Okay, I have something like this. Very weird. I got something like this. Yeah. Okay. And then it has to be between here and here. Okay, and then what am I plotting? This is y equals to fx minus gx. Like that. Can all right. So which part of the blue color graph is in between the two red lines? We are talking about this region over here. So this is my region that I'm concerned with. Okay, so this is the part that I'm concerned with. And so because of this, right, the parts, the section which I'm interested in here and over here. So the x values that I want are actually over here. Okay, like that. Can Okay, so you just need to find the intersection, Okay, then your answer would be okay, x between this and this. Okay, or you can straight away find, okay, then this means that a will be equals to some value over here. Okay, can, so you go back home and then you fill in the blanks lah. Part 1. For part 1, this one. Okay, but it's taking away some time. Okay, can. I will do part 1 then. Okay. Okay, but this will take some time, so you pardon me. Okay, so this is part 2. Okay, part 1. Okay, since you asked, okay, here I go. Okay, so differentiating y, so we have 1 over 1 plus y square, chain rule, dy dx. Okay, then you cross multiply, you get 1 plus x square, dy over dx, and then half 1 plus y square. Okay, so this one shown already. Second part, okay, we will differentiate implicitly. So I will copy, differentiate, okay, and then differentiate, copy. Okay, then half on the outside. Okay, differentiating this, right, would give me 2y, and then chain rule dy dx. Can, so you need to differentiate the square, then you differentiate the y. Okay, so this one itself will give me, okay, 1 plus x squared. Let's simplify. This one would be y minus 2x dy dx. Okay, you get something like that? Okay, all right, so with this, okay, so let's do some landmarking. This is equation 1. First derivative, equation 2. Okay, second derivative, equation 3. So one more round to find my equation 4. So copy, differentiate, then differentiate, copy. Okay, then same thing, copy, differentiate. Okay, this one, the differentiation, right? Okay, let's be a bit careful. Okay, differentiate y, I will get dy dx. Differentiate negative 2x will be negative 2. Okay, then I will have a dy dx over here. So this one, I will let this be equation 4. No point simplifying. Okay, I'll just let it be like that. Okay, so when we're doing Maclaurin series, right, our x needs to be 0. The center is at 0. So y equals to tangent half of tangent inverse 0, which is 0. So tangent 0 is 0. Okay? Now, then from equation 2, right, your y is 0, x is 0 already, correct? So immediately you can see that your dy dx itself is equals to half. Okay? From this equation over here, okay, this one is 0, so this whole thing is 1. Okay, this is 0 minus 2 times 0. So this whole thing is 0, right? This whole thing is 0, right? So this whole thing, the second derivative is equal to 0 straight away. Okay, third derivative. Okay, this one is 1. Oh, okay, sorry, third derivative. Okay, so this thing is 1 and third derivative. Okay, so this will be the key. Then the rest, right, throw over, sorry. Then this one, right, throw over to this side and evaluate together, right? So this thing will be 0. Okay, this thing, oh, sorry, this thing is half minus 2 times half. Okay, so this one you get something. Then this one move over here also becomes 0, right? So this one over here, right, half minus 2, negative 3 over 2 times half. So negative 3 over 4, lor. Okay, so far, okay, your constants, okay? Do you get these numbers? Until the square, not the cube, not the third derivative. Okay, so because of that, the Maclaurin series of this would be, okay, 0 factorial over, sorry, 0 derivative over 0 factorial x power 0. First derivative, 1 factorial x power 1. Second derivative, 2 factorial x power 2. Third derivative, 3 factorial x power 3, and so on and so forth. So this one, first one is 0, second is half x, third one is 0, fourth one would be minus 1 over 8. Yeah, of x cubed. Okay, then the k is 1 over 8. Negative 1 over 8. Okay, something like that. Okay, then you continue on to do for part 2 lah, on your own. Okay, using the graph. Okay, now the one that I really wanted to go through is actually part question 5. Okay, question 5, and if we have time, we look at question 6, but we see the time. Okay. Okay, ready? Okay, ready, yeah? Okay, let's look at question 5. Okay, ready? 5, 4, 3, 2, 1. Okay, question 5. Okay, using standard series from the list of formula, find the first 3 non-zero terms of the Maclaurin series. Okay, the instruction very nice. Using standard series. Okay, means that we are using MF27. Okay. Okay, so our y would be equals to 1. Okay, maybe I'll just write this directly. 1 plus ln 1 plus 3x Okay, power negative half. Okay, now we are using Maclaurin series for this one. Okay, this is the one that we will be using the Maclaurin series on. Okay, so in the Maclaurin series is 1 plus x, right? So here we just need to replace everything with 3x. Okay, so here we have 1 plus, okay, so this one, first one is 3x. Second one would be 3x squared over 2. Okay, and then we don't need the higher powers really, we need until square. Okay, we need the square over here. Okay, so this one is actually from MF 27. Okay, so using this, simplify. Okay, next thing, next problem over here, we are going to expand a trinomial. Okay, or actually expand something like this. Okay, so remember, how do we expand this? This is our A, this is our B, right? Correct? The technique that we've done in tutorial, right? So we can make use of the binomial expansion to do this. Okay, so this one to here, from here to here, MF27, the binomial one. Okay, if you can remember, it's the binomial one. But if you apply the formula, right, try to refer it and say it out, or like recite it as you write. Okay, so the first one is 1 plus, okay, n is negative half. Okay, then the x would be 3x minus 9 over 2x squared. First one, nx plus, okay, then the component is n minus 1. Okay, divided by 2 factorial using the formula. Okay, and then this term over here need to square. Okay, and so on and so forth. Okay, now let's expand. So 1 minus 3 over 2x plus 9 over 4x squared. So this one is safe. Okay, here, right, the coefficient, okay, let's do some simple math. This would be plus 3 over 8. Okay, now inside over here, right, we don't need to do so much work because 3x squared is 9x squared, 3x whole thing square. Then, right, if you further expand, right, you will get an x cubed and x power 4 term, correct? And we don't need those terms. So we just let it be lor. Okay, and because of that, 1 minus 3 over 2x plus 45 over 8 x squared, and so on and so forth. Okay, so this is part 1. Okay, part B. Okay, deduce the approximate value from 0 to 1 y dx. So this will be approximately, we're going to approximate using the expression over here, which we have already found, because the polynomial will be easy to calculate. Okay, so this is why we approximately equals to. Okay, and this is not a difficult thing to integrate, so this will be just like that. Okay, so wait, hold on. This one, right, they never say anything, don't need exact, right? They never say anything, right? Okay, GC. Okay, this one make use of GC. Right, deduce, right? Just 1 mark, right? Okay, explain why the approximation is not good. Okay, why is it not good? Why is the approximation not a good approximation? What do we need to check for a accurate approximation? Graph is one, the other method is graph is what? Range of validity, right? Something like that. Okay, so let's take a look at our MF 27. Sorry, I go out for a while. Okay, MF 27, right? Okay, let's take a look at what did we use to evaluate or to find out. We actually look at this, correct? We look at this one, right? Correct? And we need this one, right? Okay, so this one is a bit hard to evaluate. So what do we do is we'll look at this instead because we use the 3x. Okay, so back to this. Okay, from the function above, we expanded with 3x. So this means that we have between negative 1/3 x and 1/3. Okay, so okay, something like that. Okay, so take note, you may need to integrate your function to get an approximation, or sometimes differentiate, right? Remember in the tutorial, we differentiate to get equation of tangent. So something similar, lah. Okay? Okay, let's look at part 3. Okay, I scroll up. State the equation of tangent at x equals to 0. Okay, so this one over here, right, is state. So because we are asked to state, right, very easy. So the equation of tangent, if you were to differentiate sub x equals to 0 and so on, right, it will take some time. So actually stating, right, would be just 1 minus 3 over 2x. Just like that. The first two terms of your binomial expansion or the Maclaurin series. Sorry, yeah. Okay? The first two terms would be your equation of tangent. Because why is the equation of a line? Y equals to mx plus c. So only until x. Okay. Okay. So this one, that's why it's also state lah. Okay, we have done enough questions to derive the whole thing. So I think now for tackling exam question, right, you see this, then we just do straight away already. Okay, part B. Part B, we are talking about small angle approximation. Oh. Okay, part B, we are talking about small angle approximation. So over here, we are going to approximate cosine of 2x divided by 1 minus sine x. Okay? Can All right, so how do we do this? Okay, making use of your MF27. Okay, now we are going to approximate using the cosine and sine functions. Okay, so we are going to make use of these two. Okay, we are going to make use of sine and cosine. For small angle approximation, we will stop at x. For cosine, right? For sine, we stop at x. For cosine, we stop at x squared. So we're only making use of the front few terms like that. Okay, so cosine 2x, right? If you were to approximate, this is approximately equals to 1 minus half 2x squared. Okay, then for sine x, this would be 1 minus x like that. Okay, so here we will have 1 minus 2x squared over 1 minus x, which we can write something like this. Power negative 1. Okay, all right. Now, then the next thing to do, right, is 1 minus 2x squared. Now, shortcut. Okay. It should be, if you do this long enough, this 1 over 1 minus x, right, should be a very easy thing to do. Okay, if you have done this enough, right, This one, you can straight away write 1 plus x squared, and so on and so forth. Okay? Okay, now 1 plus x squared. If you think about it, right, there is also a symmetry or link between this and your GP, lah, right? Common ratio is x. You are summing to infinity. So 1 over 1 minus x for small numbers. R less than 1, so small number. Okay? Something like that. Okay? So with this, you can expand and get something like 1 plus x minus x squared and so on and so forth. Okay? So your A equals to B equals to 1, C equals to negative 1. Okay? Okay. Um, okay. Now looking at the time, right? Okay, let's do this. Let's finish up question 6. Okay, let's finish up question 6 and a little bit of question 7. Okay, a little bit of question 7. Okay, and then for the remaining parts, right, you try your own, but I will go through complex numbers during tutorial itself. Okay, so the remaining tutorial will go through complex numbers. Okay, can all right. So with this, I will quickly go on to question 6. Okay. Okay, moving on to question 6. Can I push one more? Okay, the diagram over here shows a circle, center O, radius R. Okay, so let's mark out R and R over here. R and R. Okay, AOB is theta radians. AC is a tangent, so we get a 90 degree. OBC is a straight line. Okay, given that this is sufficiently small for these and higher powers to be neglected. Okay, nice. Correct. Okay, and by considering the length of OC, so means we need to pay attention at OC. Show that BC, okay, show that this BC over here will be equals to half R theta squared. Okay, then deduce the parameter of the shaded region ABC is approximately that. Okay, so for physics students, H1, H2 physics, you have the benefit already. How to find CB? Where to find the CB? How, physics students? R sine theta, okay? So your this one over here, right? Technically speaking, this is the, okay, you need to use your basic trigo. Okay, so cosine theta is equals to adjacent over hypo. So your hypo equals to R over cos theta. Can? Something like that. Can? So making use of basic trigo, you have something like that. Now we are going to find BC. So BC will be equals to the long length minus away R. Okay. Now, if you want to compact a bit, actually don't need compact lah. This one we just do by hand. Or actually, should we do this step? Okay, no. Let me shift this below. Because this one, if you do right, later headache. So we do one by one first. Okay. Here, right, will be approximately, we can use the small angle already. R over 1 minus theta square over 2. In a way, yes lah. In a way, yes, the double angle formula. Okay. In a way. Okay. So this one over here, this would be equals to, okay, r times 1 minus theta square over 2 power -1. Okay. And for this, we will need to do the binomial expansion a little bit. Okay, we need to do the binomial expansion for a little bit. Okay, so this will be r, okay, 1, okay, plus n times this, okay, plus n minus 1 over 2 factorial, then this one square, correct? And so on and so forth. Theta square and square some more, so on and so forth, correct? But because this is sufficiently small, right? So this one over here can ignore, right? Power 4 can ignore, right? So what do we have? We have r1 plus half theta square. Okay, then last but not least, we have our BC, which is our r over cosine theta minus r. So this one is r1 plus half. So from above, minus the r. Okay, minus away r. So this will be just half r theta square. Okay, so this is BC. Okay, deduce the perimeter of the shaded region ABC is approximately equals to that. Okay, so what is the perimeter of the shaded area? Okay, okay, perimeter, we are looking for CB plus arc AB plus AC. Okay, perimeter, right? Like EMF. Okay, so just now our BC is half. Okay, BC is approximately half r theta square. AB, right? This one is arc length. Arc length is r theta. Remember from your EMF, r theta in radian mode. AC over here, because we are dealing with a right angle triangle. Okay, because we are dealing with a right triangle, right? This one over here, we have the r over here. What is this length? Okay, so tangent theta is equals to AC opposite over adjacent, right? So AC would be, wow. Okay, let's not use tangent. Cause tangent a bit, whoa, correct. Okay, so this one over here, half r square theta, half, yeah, r theta square. Okay, then this is AC. Can? All right, so AC would be equals to, okay, AC over the hypo would be equals to sine theta lah, correct? So AC would be roughly equals to half r theta square sine theta like that. Okay, can? Okay, so putting this in, yeah, very good. So because of this, right, half r theta square plus r theta plus half r square theta, small angle approximation, this one will become theta. Okay, so this one will be the theta square already. So your half and half will become 1. Okay, different. So half r plus r square theta. Am I doing this right? Okay, sorry. Okay, taking the r out. Okay, half theta square plus theta plus half r theta square also. Sorry. I'm wrong. Okay, this one is wrong. Sorry. This one is wrong. This one is wrong. This one is wrong over here. Okay. This part over here is wrong. Sorry, my bad. Okay, sorry, this part. Okay. This one over here, I should put OC. So this is OC. Okay, so this one will be OC sine theta. Okay, so what is OC? OC was this just now. Sorry, my bad. Okay, then sine theta. Then approximately, and then we get another theta over here. Okay, so let's expand this. Okay, you get another r theta plus half r theta cube. And this one we also can ignore because it is theta cube already. So adding everything up, so bring our r out, I have half theta square plus 2 theta. Yes. Okay, so this one shown. Okay, last one. Okay, last one, question 7. I won't do everything, but I'll just highlight something important. Okay, last one. Okay, question 7. Ready? Let's go. Okay, 7. Okay, expand this in ascending powers of x up to and including the term in x squared. So this one you take your time to do. This is binomial. Okay, second part. Find the range of the values of x for which the above expansion is valid. So now, because we are expanding two things, we have x minus 2, okay, power negative 1, plus 1 minus 2x power negative half, correct? This one we can need to readjust to negative 2, negative 1, okay? And then we have something like 1 minus x over 2 lah. Okay? Can right? So this was what we are supposed to do, right? Okay, so from here, right, you can continue to expand, so which is, you should do at the beginning. But let's look again at the range of validity, okay? So how do we analyze the range of validity? Is from here and from here. Can all right, so range of validity would be x over 2 modulus, okay? And this one would be less than 1 because this is binomial expansion. Similarly, from the other side, your 2x modulus also should be less than 1. Okay, let's multiply by 2 first because 2 is a positive number. So mod x less than 2. Then open up the modulus. This will be between negative 2 and 2. The other side, divide by 2. So mod x will be less than half. So open up the modulus. We will take something like this. So the full concept is we need to draw a number line. Okay. We will put in this inequality over here. Okay, this is the full picture. So this one would be for this. Okay, then for this one over here, I'm going to put somewhere like this. Okay, so it will be something like this. Now, because right, we are solving simultaneous inequality. Okay, because right, we must fulfill both conditions. Okay, so when we want to fulfill both conditions, we are solving a simultaneous inequality. What do we need to do? The concept is we need to take the intersection part or the overlapping part, which is over here. So the overlapping part is over here. Okay, and because of this, right, our full range of validity would be between negative half to half non-inclusive. Okay, so this is the full picture. Okay, however, okay, do we need to write all this stuff? Don't need, because only 1 mark. Okay, so if from here, right, you should be able to, okay, from here, right, you just need to observe this, write this out, write these two things out, then straight away jump to range validity already, if you can see. Straight away see this, do fast. Okay, do faster, because this, right, will give you 2, this will give you half, what, correct? So take the smaller range, take the half. Okay, so that it will give you the overlap. Okay, so one more time, all this rubbish over here, right, no marks one. Okay, because the last mark over here, this is a B1 mark. Okay, so the thing is that the full concept, you need to understand that you need to compare these two, but there's no need to work so hard because they don't need to us to show. Okay, so because of this, right, you just need to look at this, get your range of validity out. Okay, now if you want to do slowly, do pencil on the side lah. Okay, don't need to work so hard, can can. Now in tutorial and here I show you the full picture, but exam, we apply exam strategy. Typically this is 4 marks, right? 3 marks go up to the expansion, 1 mark for range of validity. Okay, so we let it be. Can okay, the final one. Okay, using the substitution to estimate root 5, so we substitute 1/10 left hand side, right hand side. Okay, then we will make root 5 the subject somewhere. Okay, remember, don't reciprocate. You can throw the negative 1/10, yes. You can throw the 1/10. Once you sub everything in, right, just throw. But the root 5, don't try not to reciprocate. We rationalize it if possible. Correct, root 5/5. Then you throw the denominator up to the other side. Okay? Something like that. Okay, all right, so I think let's leave this hanging. Thank you for once again spending your time here with me. The complex portion and pop quiz, I'll give it to you during tutorial over tomorrow and Wednesday. Okay, then Thursday we go for war. Okay, the war no casualty one. So yeah, thank you so much for staying back and listening to me. Thank you. Love you. Oh, thank you. You got trial.